A radical function. We've seen it before. A function that involves a radical with a variable in the radicand. Example, y equals square root of x, or y equals 4 times root 5 plus x are both considered to be radical functions. So as an investigation, we always talk about getting a good sense of what our base radical function looks like. So if we were to take this table of values here and substitute it into our base radical function, well, it's -4, this value would not exist, so it does not exist. Same with the -1. Substitute 0 in, we'd get 0. Substitute 1 in, we'd get 1. 4 in, we'd get a 2. And the square root of 9 would give me 3. So then if I were to plot each of these points would not exist. A restriction on our domain with radical functions. My base function would look something like this. Okay, so a base radical function is like half a parabola that opens up and to the right. Okay. Radical functions will have restrictions set on since the square root of a negative value is not possible. Okay, so in this case, our domain is obviously x has to be greater than or equal to 0, where x belongs to the real numbers. So, and we've already worked with transformations a little bit with radical functions, but we're going to go into a little bit more depth and just work with them specifically with radical functions. So transformation is equal to any other function. Okay, some key notes. Stretches will not change the domain or range of a function. Okay, so if we apply a stretch factor, regardless of horizontal or vertical, it will not change the domain at all, or the range. Okay. Reflection will change the inequality sign of the okay, which kind of makes sense. For example, if we reflected this in the line y in the y-axis and the graph now opens, domain would now be less than 0 instead of greater than, right? So it changes that inequality sign. Translations will change the value of the domain or range. Right, so if all of a sudden we translated this graph 4 units to the right, the domain would now change to x is greater than or equal to 4 instead of 0. Okay, so these are some important notes to remember. Stretches aren't going to change the domain and change the shape of the graph. Reflections will change the inequality of the domain or range, and translations are going to actually change the value of it. Okay. How do transformations affect radical functions? The same way as we've talked in transformations. So given the function y equals a root b, again, you notice how our b factor is factored out of x minus h plus k. So same type of thing. Translations relates to our k value. Horizontal translations relate to our h value. Reflection in the x-axis, that would be applied to a negative a. Reflection in the y-axis would be, our b value would be negative. Vertical stretch about the is our a factor, and a horizontal stretch about the y-axis is the reciprocal of our b factor. So we're literally learning nothing new today. We're just on transformations with radical functions. So the first example, the transformations y equals 3 root negative x plus 1, the function y equals root x. Describe each of the transformations, state the domain and range of the transform function, and then sketch the transform function. Okay, so describe each of the transformations. Well, similarly to our transformations unit, I cannot relation until I've talked about this stretch. And to talk about this stretch, I need to always factor out this b value first. So I'm going to rewrite this equation. 3 root negative, so I'm going to factor out a negative 1, and I'm actually left with an x minus 1 in my set of brackets. Okay, so let's describe our transformations. So a value is going to represent a vertical stretch. Okay, so we have a vertical stretch by a factor of 3. We have a reflection in the y-axis, and we have a horizontal translation of 1 unit right. Okay, so there. State the domain and range. Well, why don't we sketch our graph first, and then we'll talk about the domain and range after. Okay, so again, I'm always going to think about my original base function, so I'm just going to give a quick sketch base function, which always looks like this. So this is always y equals root x. And just like transformations, we want to apply our transformations in the correct order. So the first thing I'm going to do is I'm going to vertically stretch this graph by 3. My y values, here, this has a distance of 1, that's now going to be 3. This distance of 2 is now going to be 6. This is 9. And the 0, 0 point's not going to change after my stretch. Maybe more distinct dotted line. Okay, so there is my stretch. Now going to reflect this graph now across the y-axis. So then now those points would be here. So now another dotted line. Oh, sorry. Let's redo that. Our x values are not changing, so that should be there. Oops, that should be there. At 4 and 6, there, that looks better. And at 9 and negative 9 and 9. So this is now after my stretch, or my reflection. And now finally, I'm going to move this 1 unit to the right. So my final graph is going to look like this. There's my final graph. Okay, so if I were to talk about my domain, so if we were to consider our original function was any greater than or equal to 0, out a horizontal reflection in that, so that's going to change my inequality of my domain. So my domain should now be anything less than or equal to 10 initially, but then the translation was 1 unit to the right. So this domain value needs to be 1, which is clearly less than or equal to 1. And then my range value doesn't change from my original function, okay, because a stretch doesn't affect the range, and I didn't reflect or translate it vertically, so my range should just be everything greater than or equal to 0. All right, moving on to example number 2. It says, write the equation of a radical function in the form root b of x minus h plus k for each of the following below. Y equals root x has been vertically and horizontally stretched by a factor of 1/2, reflected in the y-axis, and then horizontally translated 3 units left. So we want to apply these transformations in the proper order. So again, I'm going to apply my stretches first. So my new equation, the first step, would be y equals vertically by 1/2, so my a value would be 1/2, root horizontally stretched by 1/2, so I'm going to reciprocate that value when I substitute it in value, and I get root 2x. So this is my stretch. Next, I'm going to do my reflection. So it's reflected in the y-axis, means I want to apply a negative, technically just to my x value. But a 2 times a negative x would really be negative 2x. And then lastly, I am going to translate this 3 units left. And my translation, again, I want to apply just to my x coordinate, so I'm going to put that in a set of brackets. It would be x plus 3. Okay, you could expand that inside your bracket if you wanted to. Should be a positive. And to just make it s6 would also be acceptable. Both of these answers would be fine. Okay, so what happens when we're just given the graph? How do we write the equation? So you always want to consider our base function and what is happening base function. So let's sort of visualize our base function. Okay. So visually, what has kind of happened here? Okay. So to me, when I look at this graph, if I stretch this graph vertically or horizontally, this point 0, 0 would not change, or even if I reflected it. So because this point has changed, this tells me there's definitely been a translation of 4 units down at some point. Because the graph is now opening to the left, I can clearly see there is a horizontal reflection or a reflection in the y-axis. So I'm just going to describe what's happening here. Reflection in y-axis. Translate vertical translation of 4 down. And then we want to consider like the shape of the graph. Has the shape of the graph changed? So if I were to consider these 2 points, horizontally the distance is 1, vertically the distance is also 1. So if I compare that distance between kind of these same 2 points, the horizontal distance is still 1. So to change it all. What has changed is the vertical distance between these 2 points. Now 2. So this tells me that there's been a vertical stretch by a factor of 2. All right, so what is my new equation? So again, I want to apply these in order. So I'm going to do my stretch first. Y equals 2 root x. I am then going to do my reflection in the y-axis, which would be 2 root negative x. I am now going to translate this 4 units down. So my final equation would be 2 root negative x minus 4. All right, and then the last one. Okay, so how has the function y equals been changed if the domain is now this? Okay, so thinking of our base function, y equals root x. The domain of this base function would be greater than or equal to 0. The range of this base function would be y is greater than or equal to 0. So thinking about those notes that we had talked about earlier, stretches do not affect the domain, affect the inequality of the domain and range, and translations will affect the value range. So when I look at this, my domain, the inequality has changed from a greater than sign to a less than sign. So this tells me there has been a reflection in the y-axis. Okay, it's clean. Okay. The inequality did not change for the range, so there's no reflection, no vertical reflection. Okay. What else has changed? The value of my domain has changed to a -2, so this tells me there is a horizontal translation of 2 left. -2 is a negative direction, so I'm going to go left. And the 5 tells me that there has been a vertical translation of 5 units up. So what would be my equation? So I'm going to find my reflection, which would be a -x. I am now going to apply my translations, which I want to apply just to my x value. So plus 2, in brackets would be plus 2, and then I would do 5 units up. So the equation would be y equals root negative bracket x plus 2 as 5. And that is transformations with radicals.